Hello everyone, welcome once again to our revision series for UTME, WASSCE and WASSCE students. This is science tutorial where we use simplified methods in ensuring that students understand the principle of sciences. Now this is a special edition, like you know, which is an edition designed specifically for the preparation of students as far as these exams are concerned, as the WASSCE, the WASSCE, and the UTME. We are taking our revision topic by topic, and each topic we consider will now look at questions that are associated with that particular topic. And it will be very, very important that you look at your past questions. After watching each of the video, just go to the past question and answer questions that are related to the topic that was treated in that particular video. All right. Now, today we are going to look at elasticity of materials, and we are still on physics. Remember, this program is not only for physics as a subject. We are also going to consider other subjects. We will look at chemistry, we look at mathematics, and we also look at biology. That's why it is science tutorial, all the sciences. Our aim is that our students will stay away from malpractice and write their exams by themselves and see what they can actually do. These exams are not difficult. It's just that you have phobia for most of the subjects that you study at school, and that's why it seems as if it's very difficult to pass exams these days. But with the help of this revision, I believe that you are going to go far in succeeding in your exams. So today we want to look at the elasticity of materials on physics, and we know that in the way they structure physics question in WASSCE, for example, they have question 1 to 7, and they have 8, 9, 10, 11, and 12. Elasticity, questions on elasticity will be seen between question 1 to 11. Virtually every year they will bring a question there from elasticity, and also other topics here that they can bring questions on is polarization of light. They also look at projectile motion, then conduction of electricity by liquid and gases, that's the electrolysis for liquid, and then the duality of matter, then semiconductors. All these topics I just mentioned, and you need to take note of them. If you go to the syllabus, you will see that there is an area peculiar for your country. Maybe you are watching this video from Ghana, or you are watching this video from Gambia. You will now discover that there is an area of the syllabus that is peculiar for your country. That from that area they are going to draft these questions. But in the new syllabus, it's a general question now, structured for everyone. So go to that section of the syllabus and see those topics. Those topics will appear. The questions from those topics will appear from question 1 to 7. And the students are expected to answer 5 questions from there, each carrying 3 marks. Imagine if you're able to answer these 5 questions properly, you are going to have 15 marks. That's such a huge mark in physics. Then 8, 9, 10, 12, 10, 11, 12. Questions from other aspects of physics. Mechanics may take question 8, heat may take question 9, then question 10 may be on wave and optics. Then we now have 11, which may be mainly on electricity and electromagnetism, and then 12 is usually questions on nuclear physics. So why I have to do this preliminary or this introduction is for you to know the topics to focus attention on if you really want to succeed in your exam. Because succeeding in exam is not all about reading your books or studying your books. There are other things that you need to know. If you don't have the syllabus, how will you know the area or the content, the scope that you need to cover in each of the topic or in each of the subjects that you are going to offer? All right, enough of that introduction. We want to look at elasticity of materials. Remember, it's revision, so we will not be going in details. We'll just be picking the important points that are necessary as far as your exams are concerned. So make sure you follow me. Stay away from all forms of distraction as we introduce elasticity. We may not finish it in a single video because I want it to be snappy so that you can actually comprehend it. All right, let's begin this wonderful journey on elasticity of materials. Now, when we say that, when we talk about elasticity, we mean a material, the ability of a material to return to its original shape after the application of a force. When a body returns to its original shape after the application of a force, that body is elastic. For example, you see I apply force on this rubber, and when I remove the force, then the rubber returns to its original what? Original shape. So this is actually elastic. So the ability of a material or a substance to return to its original shape after the application of a force, that ability is what we call elasticity. Elasticity. So we say that elasticity is the ability of a substance, the ability of a substance to return to its original shape after the application of a force. After the application of a force. So when you apply a force on a given material, and after the application of that force, that material returns to its original shape, that material is said to be what? Elastic. And that phenomenon, or that property, is what we call elasticity. Elasticity. Now, we have so many substances that are elastic. I've just talked about rubber. Metals can also be elastic, because when you, in basic technology, in the junior secondary, when we did properties of metal, even in your chemistry, when you look at physical properties of metals, one of them is elasticity. It's elasticity. Now, for us to actually study elasticity, there is a law. There is a law we need to look at. Now, see, this is the original size of this. The moment you begin to apply force, we discover that the size will be doing what? Increasing. The size will be increasing. So that increase in size is extension. Now, you know that apart from applying a force that extends a material, you can also compress a material. Like if you have a spring, you can compress a spring. You know, the shock absorber in a car can also compress, and when the force is released, it returns to its original size. So the extension can also be in the other direction when the size is being reduced. So it's either there is increase in size or there is reduction in size by the application of force. But we just use the term extension for both of them, because a force can be the extensive force, a force that extends a body, or compressive, a force that reduces the size of a body. In both cases, all we know is that the material is what? Elastic, or the substance is elastic. So the increase in size is what we call what? Extension. Now, there is a law that we need to look at, and that law is the law we call the Hooke's law. Remember, it's revision that we are looking at. There's a law that is very, very important, what we call the Hooke's law. In the study of elasticity, this states that the applied force on an elastic material is directly proportional to this extension, provided that the elastic limit is not exceeded. Provided that the elastic limit is not exceeded. The force applied is proportional, directly proportional to the what? To the extension produced, provided that the elastic limit is not exceeded. Now, the elastic limit is a term that we will now look at, because we know what a force is, we know what extension is, but there is a condition for this law to actually be applicable on elastic material. We say that the elastic limit will not be exceeded. We were coming to talk about elastic limit. Now, you see, if I'm increasing the force, the extension is increasing. So there is a direct proportion between the force and the what? Extension. Increase in force will bring about increase in the what? Extension, provided you did not exceed what? Elastic limit. What it means is that once elastic limit is exceeded here, then this direct proportional relationship between the force and the extension will cease to do what? Exist. So we look at this, look at this, look at this. So increase in force will now increase the what? Extension. Now, let's put this mathematically. We're going to revisit elastic limit by the time we look at other terms that are associated with what? With elasticity. So keep this in mind, elastic limit. We say that force is directly proportional to extension, provided that you did not exceed the what? The elastic limit. So if we put it by mathematics, if force is F, so we say F is directly proportional to what? To extension. So if I remove proportionality sign, you know what we do in variation from your mathematics. We introduce a constant. I'm using E as a constant. So here where F is the word force in Newton, we have done dimension analysis and we know that force is measured in Newton. E is extension in the SI unit of meter, which is M, and then K is the word proportionality constant. Proportionality constant. Constant known as the force constant or elastic constant. So this is sort of equation one. Let me call it 1A because I want to do another thing here. So what it means that force is proportional to E. Increase in force will bring about increase in the what? In the extension of the body. In the extension produced when you apply the force. Now K is our constant. If you make K the subject of formula here, we're going to have K is equal to force over extension. Let me call this equation 1B. I know that 12 then it's just about transposition, change of formula. That's why I just call this 1A and 1B. Take note of them. Now, what can possibly be the unit of force constant? Let's see. Force constant. What is the unit of force? Force is in Newton. Extension is in meter. So, force constant, Newton per meter. So, the unit of force constant is Newton per watt per meter. That's Newton per meter. I can write it as Newton per meter. So, by definition here, you say this force per unit length. Force per unit length. The force that we produce unit extension is what we call the what? The force constant. So, force constant is the force that we produce a unit what? Extension. So that force that we produce 1 meter extension is what we call what? Force constant. So force constant or elastic constant. Elastic constant is the force that we produce a unit extension in an elastic body. The force that will produce a unit extension in an elastic material or elastic body. Now, one thing we need to take note of also is that the nature of extension or the extent of extension in a given body depends on this word, force constant. So the extension we have in copper and the extension we have in iron, they are not the same because iron has a different force constant from what? From copper. So this force constant depends on the stiffness. Is what accounts for the stiffness, the refusal of a body to actually extend. Like the force constant talks about the stiffness of this rubber, and that's the force constant. So if you have a spiral spring and you are trying to actually extend it, the force constant deals with the what? Stiffness of that material. The stiffness of the material is actually the force constant. So force constant is related or is associated with the stiffness of a material. The stiffness, the force constant is associated with the stiffness of a material. The force constant is associated with the stiffness of materials. Now, we have said a few things about the force constant. We have also said that the unit of force constant in Newton per meter. We have also said that elastic constant or force constant is the force that we produce 1 meter extension, unit extension. What it means is that if a body is 30 meter long and it moves to 31 meter, the extension is just 1 meter. The force required to move it from 30 meter to 31 meter, just 1 meter extension. And that's the force constant. That's why it's called force per unit length. For a unit length, just 1 unit length. All right, 1 meter length. A unit length is 1 meter length. All right. Now, we need to generate some mathematical expressions from here, but we need to make some statements before we start generating those expressions. And what are the statements that we need to make quickly? You know, before a body can extend, that body we have an original size, an original length. An original length, yes. The body that we extend, like here, before you start extending this body, has an original length before you now start extending it. So we want to see how we can actually relate this with the equations we have derived so far. Now, one more statement before the mathematical statement, because this last statement is necessary for the mathematical expressions that we want to generate. And what is that statement? The elastic constant, the elastic or force constant is the same for a given material or given substance or body. It's the same. It's the same for a given body. So it means that if I have iron, the particular material, its force constant will be the same for that material. If you have a given spiral spring like this, and you add a load of 20 Newton on it, you remove it, the force constant obtained by adding 20 Newton on this spiral spring will be the same force constant you're going to obtain when you add 100 Newton on the same spiral spring. You see that now? So it's constant for a given body, but will not be constant for when you change the body. So if I have spiral spring A made of a different material, and I have spiral spring B made of a different material, the force constant here and the force constant here will not be what? Will not be the same. They will not be the same. All right. Now, quickly, there is need for us to go to a short break. And when we return from that break, we are going to now look at the mathematical expressions that are necessary for our calculation. Don't go too far. Don't go anywhere. Stay around and go through this video over and over again until you have understood every part of it. Continue to watch science tutorial and continue to get involved in this revision. Thank you and God bless you.